Welcome back, all you mathematical minds, to a video on analyzing graphs for the number and type of solutions they will have. This would be easier for you if you had a graphing calculator, if you want to see what these graphs are doing for yourself. But I know what the answers to these graphs are going to look like, so I'm just going to sketch them for you because we're more along the lines going to talk about what type of solutions they're going to have. So I want you to know, for the purpose of comparing different graphs, all of these are x cubes. So these are all cubic or third degree functions. As you can see, x times x times x would give us x cubed. X times x times x will give us x cubed. And x times x squared is still going to give us x cubed. Also, they're all positive. The only thing I have done is slightly changed each one for types of solutions. So if you were to type this into your graphing calculator, you should know that your zeros are going to be negative 4, 0, positive 3, 0, and positive 6, 0. So this graph is going to pass through the x-axis at those 3 points. Now, if you were to type that into your graphing calculator, you're going to see a graph that looks something like this. I don't have the perfect solution because I just want to talk about what is happening. So if you remember correctly, we said that x cubed functions, the degree is the number of possible solutions. So there are 3 possible solutions to an x cubed function. But now by looking at the graph, we can determine how many of each kind they have. So we see that it crosses the x-axis once, twice, 3 times. Whenever it touches the x-axis, that's how many real solutions you have. So this one has 3 real solutions, which means it has 0 imaginary solutions. Okay? So in the next graph, what I have done is I tweaked it a little bit, so now we have negative 4, 0 again, but we have 3, 0 and another 3, 0 because we have x minus 3 twice. Well, we only would say that there is x equals 3. We can only graph the coordinate 3, 0 once. So this is what's known as a double root. And graphically, that's going to change things a little bit. So we're still going to have our negative 4, 0, but we're going to have our 3, 0. It's still going to start low and finish high, but what it does is it bounces off 3, 0. Whenever it bounces, that's a double root. Okay, so if it bounces off the x-axis, it's actually a double root, which means if you look at that, since it's still 3 possible solutions, we have 2 that are real because it crosses once and bounces once. But we still have 0 imaginary. And the reason why is because that's considered a double root. If we look at the solutions, we have negative 4, 3, and 3. So we don't have any imaginary solutions to worry about. Now, when does an imaginary solution come into play if we're talking about an x to the 3rd power? And that would be an example like this. We would know this is negative 4, 0, and if we were to solve this, we would have plus or minus 3i, 0. Which means 2 of our solutions are imaginary. We can see that. Here's a real number, and here are 2 imaginary numbers because of the plus or minus. Graphically, it's still going to go through the negative 4, but it's never going to come back down and touch the x-axis again. So it'll look something like this. And that means we cross the x-axis once. So we have 1 real solution, but we have 2 imaginary. Now, why does this one not have an imaginary if it only has 2? Because this, again, is a double root. 3, 0 happened twice when you solve it algebraically. And the other thing you need to know, and write this down, imaginary numbers will always come in pairs. You will never have an odd number of imaginary solutions, because imaginary solutions will always take place when you are taking the square root of a negative number. And whenever we're solving by square roots, there is always a plus or minus. Okay? So whenever you're solving by square roots, you have plus or minus. That's the only way to get an imaginary number. So imaginary numbers come in pairs. You should never say that we have 2 real and 1 imaginary. Imaginary will always come in pairs. So I have only showed you cubics, but just to give you an idea, what if I were to tell you that this graph right here is some sort of x to the 4th power? So if that was something x to the 4th, all I want you to do is think about how many real solutions are there and how many imaginary. So as you can see, there are 4 that are possible. Now go count your reals. Crosses through, that's 1 solution. Crosses through again, that's 1 solution. So we have 2 reals, but none of them are double roots. So therefore you have to have 2 imaginary. Okay? And if we were to do something very, very similar, but this time I were to go through, come back up, and then if I were to go down and bounce, that one is considered a double root. So the red one, we would have 4 possible, and then 3 of them are real, and there are 0 imaginary. Because again, imaginary must come in pairs. So you can't have 1 imaginary. You can't have 2 because that puts you over 4. Okay, so sometimes it is a little bit less, but sometimes they'll add up to be 4. All right, that's it for this video on types of solutions from graphs. This is Longo, and I'm out. See you, bye.